Hello everyone, hope you're doing well. So today I'm recording a session, some of the interview questions which are asking and very frequently during the interviews. If you are planning to switch your job, right, you can refer this video, that will definitely help you a lot. So first question that which do come interface changes from Java 8 to Java 17, like what are the changes they did, and sealed interface, what is that in Java? Pattern matching in switch, like what are the pattern matching, how do we implement it, and what is the record in Java. So these are the 4 questions which I'm recording on it. Okay, you can go through with that complete video and get complete clarity about these all questions. Okay, now let's come to the first question, interface changes from Java 8 to Java 17. So first, that Java version with new interfaces. So what are the changes? First, Java 7 and earlier, I'm talking here till Java 7 only. So for this Java 7 and earlier, only public and abstract method we can add, and public static final, that is a constant, like a variable. So by default, we know that in interface that all the methods will be public and abstract, right? And the variables that I've declared inside it, that will be by default constant, because it is a public static and final. So static final will make a constant variable, and static means it cannot be inherited, right? So that is the main changes, that is the main thing, that is that till Java 7 onwards. But from the Java 8 onwards, what happened, right? They added 2 more method over the interface. That is a default method and static method. So default method, static method are the method which is added in Java 8 onwards. Then what is the use of them? They are a kind of method which could be non-abstract method, which I can say like that. And some of them people do ask what are the difference both of them. So the difference is that default method we may have an option where we can override it, right? Where static method is optional to, static method cannot be overridden at any cost, where default method is optional to override into a child class. So wherever is required, we can do it. So we will see examples as well. Let's complete first the definition part, then I will come to the example as well. So in the Java 8 onwards, they have added default method and static method, where default and static both are the non-abstract method. Non-abstract method, that means they are not abstract method. And default means when can we think which can be used for what purpose. So that's the option we have for the default. We can skip or we can implement in the child class, override in the child class, but static method cannot be overridden at any cost. But from the Java 9 onwards, they have added one more method in this interface, that is called private method, right? So private method, either the normal, that means non-static, and or static also. So from the Java 9 onwards, they have added private method in the interface. And from the Java 15 onwards, they have added one more interface like sealed interface. So we will look that as well. What is a sealed interface? How does it work? Okay, so these are the different changes from Java 8 to Java 17 in interface. First, Java 8, they have added default and static method. Java 9, they added private method, which could be normal or static. And Java 15, that is a preview and that is stable in Java 17, that is a sealed interface. So that is all added in the interface in the Java. Okay. Next, we are going to look what are the sealed interfaces. So sealed interfaces is an interface that restrict which class or interface can implement that. So normally when do we create the interface, right? What is the use of the interface? We do implement that interface in n number of classes. But here we are restricting them. We are restricting them and we are saying like, if I'm creating some interface, right, that will only implement by the selected classes, not all the classes, selected classes. So that we do define at the time of declaration of the sealed interface. So that is only the main use of it. You explicitly specify the allow subtype using the permit clause. So we have a one permit clause that we use when we are creating the interface itself, right? That time it does let us know, okay, how many classes can be used at the particular moment, can implement that, right? Help in better control, security and pattern matching, like in switch expression. So in the switch expression, we have one kind of rule has implemented that pattern matching. That also I will let you know what is the pattern matching, how can we implement it. So help in better control, security and pattern matching, that is the main purpose of sealed interface. Okay, next we are like what is the pattern matching in switch from the Java 20 onward. That is actually launched in Java 17, but it is stable from the Java 21 onwards, right? So from the Java 17, it was not completely implemented, and Java 21, it is finally completed. So what are the pattern matching? So like 17 introduced pattern matching in instance of. So normally what happened, right? if I want to check this instance is belong to that particular class or not, what do we use? We use instance of operator. So instance of operator we do use, and it is checking. Like for example, obj is what? Obj could be any type. Obj could be any type, and I'm checking that this obj is belong to a string. If it is a string type of object, it will say it is a string. So instance of does return true or false. Instance of does return true or false. It does check the object which you are checking here, right? That is a type of a string or not. If it is a type of a string, return true. If it is not, return false. Right? But in pattern matching, right, they are going to use kind of instance of kind of behavior in the switch. But pattern matching for switch was still a preview feature in Java 17, not final. But full stable support for the pattern matching is switch came into 21 LTS. Okay, so this is the pattern matching. So I will show you that example as well of the port pattern matching. So mainly it is going to work like an instance of, and they are checking does object is belong to that particular type or not. Okay, like for example here you can see I have one vehicle type, vehicle class, and vehicle is having like 4 or 5 child classes. Like it is having a car class, bike class, or truck class. It could be any class. I took a generic answer, right? You can fit that in your project itself. Like if it is a kind of any kind of like employee we have, right? We have a different type of child of employees, or department, or anywhere wherever you're thinking, right? If one interface having a number of implementation, right? You can take any of the example. Here I took the generic one only, so that could be fit on any scenarios. So I took a one type here, vehicle. So vehicle is a one interface, and vehicle is having like a number of child. So here we are creating the object of vehicle, and we are passing the object of vehicle. Now we are checking that simply kind of runtime polymorphism like dynamic method dispatch. So if you are aware about the dynamic method dispatch, it is easy to understand that. So in the vehicle having a like one class will become here. So here vehicle having a 3 child class, car, bike, and truck. So here vehicle it will pass any of the class. So here it is checking does this. So here normal whatever, right? We are using switch, and here we are passing the vehicle is a variable. Now here it is checking case car C, like does this vehicle we have, right? It is a type of car, it is a type of bike, or it is a type of truck. What is the type of it? So that we are checking here case car C, bike B, or truck T. What is type? If it is a type of suppose C, if it is a type of car, so first case will be true. If it is a type of bike, second case will be true. If it is a type of truck, then third case will be true, right? And it is returning the result into one particular string variable, right? So here we are just preparing that strings only, and this string is returning to the result. So all 3 cases will not be true at one time. Only one case will be true. So whichever object you are passing under the vehicle, right, that object will be true, and it will return the same kind of things in the result. So if you can compare the previous one, right, like instance of, same thing is doing like here. So here it is checking with the instance only. Does this vehicle is belongs to that particular instance or not? So this instance and that vehicle instance both are matching. If they match, this case will be true. If both are not match, then this case will not be true. It will turn the false only. So that is one example of switch in pattern matching. I will show you one example as well. How does it work? Okay. So that is the one thing in a switch pattern. Now let's understand some more example of record. So what is the record? Right? So record in Java introduced in Java 14, finalized in Java 17, 16, and available in Java 17 LTS. Right? So record is what? Record is a Java is a special kind of class designed to hold immutable data. So whenever we want to hold the immutable data, right, we have to like normally there's interview questions, right? How do we create immutable class? So record is one of them where we can create the immutable kind of data. Okay, it look like a class. Okay, how does it work? That also we'll look on it. So record in Java is a special kind of class designed to hold immutable data. It is shortened way to create a data carrier class without writing a boilerplate code like getter, toStrings, equals, and hash code. So record look like a class only, but here many things will come by default. What will come by default? You don't have to write any getters. You don't have to write any toStrings. You don't have to write any equals. You don't have to write any hash code on it. So, I mean, you don't have to overwrite it. It's by default overwrite, right? So this comes under the boilerplate code, right? Because it is repeated, actually we do use multiple times, right? So that we don't have to write it. It will come manually on it. Okay. I mean, by default we do come on it. So record in Java is a special kind of class designed to hold immutable data. It is a shortened way to create the data carries class without writing boilerplate code like getter, toString equals and hash code. Okay, so these are the some things that we have under the record. And what are the key features of record? So features of record is that first, it is an immutable by default, right? That is a field are finals, every fields are final on it, and great for DTOs. So whenever you are working with the DTOs, right? I mean data transfer object. So that time record will be the better option for that. Can implement interface? Yes, record can implement the interface also. Okay, so here we are saying showing the one example as well. So I created a one record. So public record point. So point is a one kind of name of the record which is taking two arguments x and y, and we are implementing the comparable. So comparable we are implementing and we are overriding the compare to method, and we are comparing that both of the point whichever we have, right? So what is the main advantage of record? First, it is an immutable by default in nature, and better we can go with the DTOs, right? If you want to implement that, you can go with the DTOs. And can implement interface? Yes, a record can implement the interface also. Note, in Java 17, record are stable and widely used for microservices, DTOs and data pipeline. So whenever we have like from Java like data pipeline you are designing, or DTOs or microservices, right, then record will be the best option for that. Okay, so that we have seen record, pattern matching, or this one sealed and interface changes. Now let's come to the example directly. So now let's come to this example first. So here I created our interface, my interface. So what we are looking? We are looking that changes which is having in Java 8 and Java 9. So first we'll complete this, and then we are going to cover sealed interface. Okay, so now let's look on it. So here, as you can see that in my interface, I created like one abstract method display, and I created one default method, and I created one is implementing the interface. Okay, fine. So what I'm doing here, first I'm creating one interface which is having all type of method like display, abstract method, show message, right? Default method, so static message, static method, and two private method. That is one is a non-static and one is a static, right? So inside the default, I'm calling that default method which is a private, and second we have like so static method which is calling like log static message. Now I'm creating one child class of my interface which is a my class only. So in the my class I'm implementing the my interface. So here we are just simply providing the body of display, right? So here we are I can say overriding the display method, right? We can keep it override also in the top of it. Okay, now let's come to the main class. So in the main class I'm going to create object of the my class. So my class obj equal to new my class, and second way what we have, we can simply write here my interface, right? My interface obj equal to new my class. That is a better way, or that is only that preferable way actually we do use that. So my interface obj equal to new my class, so it is having an object of the my class. Now here we are calling obj.display. Obj.display is directly called. So message also will call. So message and display. So display is an abstract method that overrided into this my class, so it will give the body of it. And obj.show message. So message what? It is a method of, I think it's a default method of this show message, right? It's a default method, so we can call directly with the child reference, right? But so static message, it's a static method, right? So static method directly called by the interface name itself. So interface name dot method name, right? So that way we can call them directly, but always remember that log message will not be called, because log message is a private method, so it will give a compile time error for us, right? So if I will run this code, you can see here I'm getting the output. Display method from the class, inside default method, logging from the private method, inside static method, logging from the private method static, right? So we can create private method as well in the Java 9 onwards, right? If you are having a Java 8 version, that time private method cannot be added on it. Okay, now let's come to the sealed interface. What are the sealed interface? Okay, so I created a one class. First I created one interface like shape. Instead of that, let me take a one more example here. So I created a one vehicle interface. So I created one vehicle interface which are having a like car, bike and truck. So when do we create the interface, right? that time itself we are asking permit. We are saying write permits, and this car, bike and truck, these are the three child classes, and they are only implement this vehicle interface. Any other interface, any other class cannot implement this vehicle interface. So that's why we are providing permit, and here we are providing, it could be car, bike or truck, whatever it is. And we are using one keyword like sealed only. If I will not use sealed here, right, that time permit will not work, right? So whenever we are creating the interface, that time we are providing how many classes can implement this particular interface. Now I am going to create a sealed class. It is an interface, right? Now I'm going to create a sealed class. So sealed class also is same kind of things, which is saying that I don't want to be extend that, right? So that means the classes which is a final class and that implement the vehicle interface, right? They are called sealed classes. Like for example, car class. Now let's open the car class. So here car class I am creating, right? So I am writing public final class car implement vehicle. So car is implementing the vehicle and it is a type of final here. That means car cannot be extendable at any cost, right? Car cannot be extended any place. So that means here car class can be waived as a sealed class, right? Same thing is happening with the bike as also, right? Bike is also like one kind of final class. So that is behaving like a sealed class. If you want to make it suppose non-sealed classes, that also we can do it. How can we use? For that time, like for example, here I have three classes, car, bike and truck. So car, bike I make as a sealed classes and truck is not a sealed classes. Why? Because it is not a final. So that means I can be extend that in other class as well, right? So let's understand truck. How can we make it non-sealed? So that time if you want to make a non-sealed class, right, that can be extended by the other class. So that means we have to use non-sealed interface, non-sealed keyword with that. So non-sealed keyword class with this truck and implement the vehicle. So that time here I am saying that I am creating a one truck class which is a non-sealed type and that can be extended by the other class. So sealed classes are the classes which cannot be inherit and non-sealed classes are the class which can be inherit, right? And sealed interface are the interface where we are allowing that this permit keywords where it will allow how many classes can implement that particular interface. So for that purpose only we are going to use sealed classes or sealed interface. So mainly we have to avoid or we have to restrict that implementation. For that purpose only we are going to use sealed class or sealed interface. Okay, so sealed interface. So we have like a better control for security and pattern matching. So these are the main use of it. Now let's understand what are the pattern matching. So we have already seen the definition, right? Now let's. Okay, so it is having a like pattern matching example where we are just checking. So here I created the three objects of vehicle. Okay, so vehicle, new car, vehicle, new bike, vehicle, new truck, right? So they all are the child, so we can create it. Now we are calling this print vehicle type and we are passing one v1 type. So first what we are passing v1 type is a car only. So first when you will call this particular method, right? So here we have a like v1 is type of what? Car. So first time it will come this condition will be true and it will return this is a car and it will display here actually. So the result we are displaying outside the switch only. So switch does return the values in the string variable. This is the result and the result is displaying. And for the second call we are passing v2. v2 is type of what? v2 is type of bike. So second time that bike will be true and third time we are passing v3 here, right? That could be truck. So if I will pass single one only, right? Let's say if I am going with the single object, like for example this one only. And let me comment this 2 now. So I have one v2 object which is having a bike type, right? So here whenever it will come in the vehicle, so vehicle will having a bike type and which one will be true? The second will be true and answer should be this is a bike. Okay, this is a bike. Now let's run this. How does it work? So you can see now I am getting this is a bike. Okay, so that way that is called pattern matching where we can call the method. So it is kind of doing instance of operator only, instance of operator work, right? Which can be checked the type of object. It is the same type or not. If it is the same type, please work it. Otherwise, do not do anything. Okay, so that is example of pattern matching. Now we are going to look one more example called record, right? The last thing that we have to cover is record. What is the record? So record, as I told, it's kind of a class, but it is immutable in nature, introduced in Java 14, finalized in Java 17, and available from the Java 17 onwards. So how does it look? Let me show you one example of it. So normally I created a one, like for example, if normal class you want to create, right? How you will do? You will create a class like this way. Class will having like variables, right? Private, final, okay, constructor we have, getters we have, right? ToString equals hash code, kind of that that we have, right? But same thing if you want to do with the record, that time I don't have to go to create this getters and ToStrings equals like that. So same kind of things which is employee class is doing, right? Same kind of things I'm doing here also. So here I'm creating a one public record. Here I'm not using class keyword, record keyword, employees, taking two argument, ID and name. So it is taking two argument and it is a one kind of record. So what first Java automatically generate what? Constructor will generate automatically, getter will generate called component access, ID or name, and ToString equals and hash code. So this all things by default will generate inside it only, right? If you want to use it, how we can use? In the main class, I just call this employee object here, create the employee object and pass this 101 and alias, right? And here you can see that I'm getting an employee.id, so it will give me 101, employee.name, alias, and with employee it will give me complete information of it. See here, normally if you will pass the reference in Java in class way, right, it will give some hexadecimal value, but here I'm not getting hexadecimal value. We are getting proper object of it. That will come if I will override ToString method in my class. If I will not override that, it will not come. So this is a kind of simple discussion of record, sealed classes, Java 17, that interface changes, right? Yeah.